your channel is like his channel, so we don't get notifications.
Well,
Oh, really?
It's rendered as a kid's
Mr.
channel.
Chow, I just want to say I'm subscribed. I love your videos.
I like your recent videos too. I like the keep on my YouTube.
I'll see how I can fix that.
When you put it kids,
Okay, we'll see. Okay, so the very first thing we would do for the first problem is that if you have something on the outside like this, you can go ahead and multiply it to everything in the inside. Okay, you can multiply it to everything in the inside. So this would be 3 times x.
3x plus 9.
Oh.
So Olivia, thank you for giving me your phone. Thank you so much. I appreciate it. You can go ahead and put it in number 1.
There's no way. Oh my gosh. You're that lazy.
Okay, so the very first thing we could do is we can, again, if you have a 3 on the outside and you have two things either being added or subtracted or more, you're going to multiply the 3 to everything in the inside. So this would be 3 times x plus 3 times 3. This one would be 3 times x and 3 times negative 2. So they're on two different sides of the equation. So we'd have 3 times negative 2. This would equal 3x plus 9 equals 3x minus 6.
Can you skip the second step when you're drawing?
You can. I am just showing you what is happening here. Okay. So the next thing we would do is we would try to move all of our variables to one side, and we try to move all our constants to the other side. So in order to move this 3x to the left-hand side, I'm going to go ahead and subtract 3x from both sides. And then I'm going to go ahead and move this 9 to the right-hand side. So I'm going to go ahead and do subtract 9 from both sides. So what I get is that this cancels out, which if that seems weird, that's good. This cancels out, so 0 is equal to negative 15. So how many people here believe that 0 is equal to negative 15?
Me.
So hopefully it's none of you, because 0 doesn't just equal 0, it doesn't equal negative 15. So in the case that this, you have something where both sides do not equal each other, then we know that this would be what we call no solution. How you would recognize this on a graph is that you would actually have we would have two lines. I'm just going to give example lines. These are not indicative of these lines here. So you would have two parallel lines with the same slope, and they would never intersect. So the reason that is because they both grow at the same rate, they both have the same slope, but because they start at different points, they would never intersect. Okay? So this is an example of no solution. Okay? This is an example of no solution. Okay, so the second example here is 4 times x plus 2 equals 9x. So in this case, 4 times x equals 4x, 4 times 2 equals 8, and then 9x we just keep the same here. The next thing we would do is we would try to move all of the exponents, all the variables to one side, and we would get 8 equals 5x. The next thing we would try to do is to get rid of the coefficient, which is the number in front of x, and then we would go ahead and divide by 5 on both sides, so x would equal 8 divided by 5. So in this case, we have one solution. Okay. We have one solution. So again, this is just practicing your algebraic skills, practicing can I distribute, can I subtract, can I divide.
Mr. Trump, on the test, do you leave it as 8/5 or 1/3?
Leaving it as an improper fraction is fine for me. Okay, so then lastly, we're going to be introduced to our last concept here. So this is the last part of our notes here, which is just that we're going to go ahead and multiply here. So we have 3 times x plus 3 times 2 equals 3x plus 6. So this would be 3x plus 6 equals 3x plus 6. So I'm going to move all the x's to the left-hand side, and I'm going to move all these 6's to the right-hand side. So I'm going to go ahead and subtract both sides by 3x. I'm going to subtract 6 from both sides, and I get 0 is equal to 0. Oh, again? Okay. Today is... Oh, that's so weird. He was here yesterday. Okay.
Thank you.
Yeah. Okay, so so the reason that when you get this, where you have 0 is equal to 0, part of this is you can understand this is when is 0 equal to 0, and if your answer is always, then it would be infinite solutions. How this looks like graphically is that you would technically have one line on top of another, and they're actually the same line. So because you're asking when do they intersect, well, they intersect everywhere on the line because they're exactly the same line. So the reason it's called infinite solutions is because they lie right on top of each other. The reason that this one would be one solution is if they are able to cross one time and only one time itself. And if you want to extend this, you can think about how would you get 2 solutions, how would you get 3 solutions, and how would you get 4 or 5 solutions. And that's an example of how you would extend things. Okay. So again, the idea is that we have no solution, one solution, and infinite solutions. And again, that's really what we just want to learn today, is that when you have a one variable equation, you could possibly get no solutions, one solution, and infinite solutions, okay? So that's really what we want to take away from today.